Voyager 1, NASA's farthest traveling thing made by us, has amazed everyone for almost 50 years. Since it launched, it's sent back key info from way out in space, teaching us tons about the universe. Lately, though, its messages have been acting weird, leaving researchers scratching their heads. These odd signals have sparked lots of debate. Are they just glitches? Or could they mean something bigger? Maybe even aliens? Let's check out these strange messages and what they might mean about what's hiding out there. The urge to figure things out has always pushed us to explore space. This led to missions like Pioneer 10 and 11, super ambitious for their time. Voyager 2 took off from Kennedy Space Center on August 20th, 1977, kicking off a changed time of space exploration. Soon after, on September 5th, 1977, Voyager 1 launched, heading past the outer planets and changing what scientists thought they knew. Each probe, about the size of a small car at 721 kilograms, traveled different paths at different speeds. 1977, Voyager 1 passed its twin in distance because of its route. From then on, Voyager 1 became key to learning about the universe, sharing discoveries that changed how we saw space. Before we talk about its recent big finds, let's remember some earlier ones. In 1979, and it was about 265 million kilometers from Earth, the spacecraft snapped great pictures of Jupiter. By January, it had spent 100 hours watching, making a time-lapse video of Jupiter spinning. These 3,750 photos gave awesome views of the planet's crazy atmosphere. During this mission, Voyager 1 spotted a ring around Jupiter and found 2 new moons, helping us learn much about the planet system. To stay on track and miss hitting Titan, or moon of Saturn, the spacecraft made some course changes. After that, the mission aimed past the solar system as the probe zipped into interstellar space at 325 million km a year. In January 1990, Voyager 1 started checking out interstellar space, going beyond our solar system. It did cool stuff like finding 4 more moons, Mimis, Enceladus, 2s, and snapping iconic pictures of the solar system's outer parts. On February 14, 1990, from about 6 billion kilometers away, Voyager 1 took the famous family portrait, a set of photos showing the inner planets. These images joined the probe's huge collection, with hundreds of pictures from encounters with gas giants. Meanwhile, Voyager 2 hit big goals, too. It clocked wind speeds on Neptune at over 2,100 kilometers per hour, 1,300 meters per second, the fastest ever seen in the solar system. Checked out Triton, Neptune's biggest moon, where it's a freezing minus 391 degrees Fahrenheit, making it one of the coldest spots around. Triton had icy geysers that shot nitrogen gas and frozen bits up to 5 kilometers high, showing its active surface. These amazing finds seriously improved our understanding of the outer solar system. Voyager 1 and 2 have been groundbreaking, showing us activity on moons we thought were dead. This made us rethink old ideas about their surfaces, Voyager 2 especially. Is the only spacecraft to visit both Uranus and Neptune up close, a feat no one else has done? NASA stretched the missions by turning off unneeded systems to save power. The mission should keep going until 2030, marking the end of a great run for the teams who put their all into it. The design of Voyager 1 and 2 was innovative. Built to turn slowly, they kept images sharp even when moving. Even before reaching the outer planets, spacecraft started sending detailed photos of Jupiter, showing swirling clouds and the huge Great Red Spot, a storm that has stumped scientists for years. One of the coolest finds was active volcanoes. On Io, one of Jupiter's moons, the spacecraft's gear picked up weird readings, later confirmed by pictures of giant volcanic plumes and a landscape remade by eruptions. One blast was 1,000 times bigger than the Mount St. Helens eruption, covering an area nearly the size of France. As the probes kept going, they got powered down bit by bit to save energy for interstellar travel. They didn't photograph Mercury or Mars because of tech limits. NASA then launched more big missions like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11 as the farthest probe from Earth. Still, Voyager 1 kept going, and after 14 years, entered interstellar space on August 25, 2012. A big, The reason these missions worked was by using gravity to slingshot the spacecraft toward their destinations while saving fuel. Instead of just engines, they grabbed the gravitational pull of planets to speed up and change direction. This let them cross huge distances with little power. As Voyager 1 got near Jupiter, the planet's gravity boosted the spacecraft's speed. Precise calculations were super important to avoid problems. These gravitational kicks helped the probes skillfully move through the solar system. Voyager 2 also used Jupiter and Saturn's gravity to get to Uranus and Neptune, showing how well this works. Looking back, researchers are keen to see what those weird signals from Voyager 1 mean. The spacecraft keeps checking out the area beyond our solar system, grabbing info from the edges of giant planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse photos showed 10 volcanic eruptions on Jupiter, found moons, and spotted a new ring. These observations helped a ton in knowing the Jovian system. It discovered 4 more moons of Saturn and sent amazing pictures of the planet and its ring system, giving fresh looks at its details. The trips by Uranus and Neptune gave key info about their atmospheres and moons, helping us know the solar system's distant parts. After finishing their planetary tours, the probes headed for interstellar space, where they keep gathering key science data. This ongoing mission broadens our grasp of what's beyond our cosmic neighborhood. As we wait for new info from Voyager 1's mystery transmissions and wonder what they mean for the universe, these spacecraft keep inspiring scientists and space fans all over. Their input remains valuable in boosting knowledge and pushing the limits of space science. The Voyager expeditions gave amazing views of the solar system and beyond, yielding awesome visuals and groundbreaking finds. Besides the tech stuff, the spacecraft carry a cultural thing meant to share Earth's story to any smart life they may meet. The Golden Record has greetings in 55 languages, music from everywhere, and natural sounds like rain and whale songs. This interstellar message in a bottle shows what humanity hopes can happen. As that smart life will someday find and get it, Voyager 1 and 2 had a wide range of science tools that revolutionized space research. These included magnetic sensors, plasma wave finders, and gear for imaging all the space conditions. The magnetometers unlocked the magnetic fields of the outer planets and their relations. Plasma sensors gave insight on how solar winds affect planetary frosts. One of the mission's biggest wins was mapping the heliosphere's edge, a region full of solar bits and magnetic forces around our solar system, as Voyager 1 approached. This edge, it saw a shift from solar stuff to interstellar matter, giving great evidence on how this boundary protects Earth from bad cosmic rays. The spacecraft found the termination shock, a spot where the solar wind slows down and gets denser. Past this is the heliosheath, a place where solar and interstellar materials mix. Voyager 2's trip gave more clarity on these outer solar regions. Its measurements mainly of Uranus's magnetic field messed up old ideas and sparked new looks. These missions didn't just boost science but hooked the public too. The breathtaking shots of remote planets and the compelling stories of the spacecraft have inspired lots of people. Iconic images like Saturn's rings and Jupiter's Great Red Spot are some of the most unforgettable pictures. In February 1990, from 6 billion kilometers away, Voyager 1 took the family portrait of the inner planets. This set of 60 pics joined the hundreds it already had from Jupiter and Saturn. Meanwhile, Voyager 2 hit some big milestones too. It recorded Neptune's winds at over 2,100 kilometers per hour, the fastest ever seen in the solar system. It checked out Triton, Neptune's biggest moon, where it's a crazy cold -391 degrees Fahrenheit. Triton has icy geysers shooting nitrogen gas and frozen stuff 5 kilometers high, showing it's an active place. These finds gave us way more insight into the outer solar system. The Voyagers showed us that moons we thought were dead are actually active. Voyager 2 is still the only spacecraft to visit Uranus and Neptune up close. NASA stretched out these missions by turning off stuff to save power. They hope to keep going. Until 2030, the Voyagers were built to spin slowly, so images wouldn't blur. Even before reaching the outer planets, they sent back detailed pics of Jupiter with its swirling clouds and the Great Red Spot, a storm that's been bugging scientists for ages. One cool find was active volcanoes on Io, a moon of Jupiter. Voyagers. Instruments spotted weird readings, which turned out to be giant volcanic plumes in a landscape shaped by eruptions. One eruption was 1,000 times stronger than Mount St. Helens, covering an area close to the size of France. As they kept going, the probes lost power to save energy for interstellar travel. They didn't grab photos of Mercury or Mars because of tech issues. NASA later launched more missions like Pioneer 10-11 and New Horizons. In February 1998, Pioneer 10 went past Pioneer 11 as the farthest probe. Voyager 1 kept going, and in August 2012, it entered interstellar space. One thing that helped these missions succeed was using gravity to slingshot around planets. This saved fuel because they used the gravity of planets to speed up and change direction. Jupiter Voyager 1 got a speed boost from the planet's gravity. This helped the probes move around the solar system without using too much energy. Voyager 2 did the same thing around Jupiter and Saturn to reach Uranus and Neptune. Researchers are now super curious about these weird signals from Voyager 1. The spacecraft keeps exploring beyond our solar system, getting info from planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse pics showed 10 volcanic eruptions on Jupiter, more moons, and a new ring. These observations helped us grasp Jupiter's system. It also found 4 more moons of Saturn and sent back awesome pics of the planet in its rings. The trips past Uranus and Neptune gave us important info about their atmospheres and moons, helping us understand the outer solar system. After checking out the planets, the probes headed to interstellar space to gather data. This helps us learn about what's beyond our cosmic neighborhood as we wait for what Voyager 1 sends back. These missions keep amazing scientists and space fans. What they've done is still critical for growing human knowledge and pushing the edge of space science. The Voyager trips gave us great views of the solar system. Besides the tech stuff, the spacecraft have a golden record. This is meant to share Earth's story with any aliens they might meet. It has greetings in 55 languages, music, and sounds like rain and whale songs. This message in a bottle shows that humans hope other civilizations will find and get it one day. Voyager 1 and 2 had a bunch of instruments that changed space research. These included sensors for magnetic fields, plasma, and cameras. The magnetometers told us about the outer planet's magnetic fields, and the plasma sensors showed how solar winds hit planetary atmospheres. Another big win was mapping the edge of the heliosphere, a region of solar particles that surrounds our solar system. As Voyager 1 got closer, it saw a change from solar particles to interstellar stuff. This showed how this boundary protects Earth from cosmic radiation. The spacecraft found the termination shock where the solar wind slows down and gets thicker. Beyond this is the heliosheath, where solar and interstellar material crash together. Voyager 2's trip helped us understand these outer regions better. Its measurements of Uranus's tilted magnetic field made us rethink old models and look closer into planetary magnetism. These missions pushed science and captured the public eye. The amazing photos of planets and the stories inspired folks. Images like Saturn's rings and Jupiter's great red spot are memorable in space history.